Hello and welcome to my Physics 2212 Lab 3. So today we're going to be talking about the behavior of a magnetic field created by a natural dipole both on and off of its axis using the Biot-Savart law. And we're going to simulate the behaviors of a magnetic field using virtual Python. So the models and principles we're going to look at today are the Biot-Savart law, mostly. So this law is used to find magnetic field due to current flow in a wire, but you could rearrange it to find the magnetic field due to a dipole from a permanent magnet. It's inversely proportional to the cube of the distance and directly proportional to dipole moment. So the main result that I found is that after finding a value of 1.77 for the dipole moment, the behavior of a magnetic field surrounding a magnet was quantified. So basically the magnitude of the net magnetic field decreased as the distance increased. The magnetic field perpendicular to the axis of the dipole was 5.24 repeating times 10 to the negative fifth tau and Tesla, and the magnetic field parallel to the axis was 1.04 times 10 to the negative fourth Tesla. So the big ideas we're going to look at otherwise are the magnetic field due to a magnetic dipole. There are specific formulas that can be derived from the previous formula that I had shown. So these suggest that magnetic field around a dipole is dependent on the dipole moment, inversely by the cube of the distance, and by the location of the observation point around the dipole. So for observation point perpendicular to the axis compared to one on the axis, the magnetic field is twice as strong. So to determine this experimentally, an experiment was conducted. So this experiment involved a cell phone, which is prepared to act as a magnetic field detector, being used to determine the magnetic field at certain points around a small bar magnet. So these field strengths were plotted proportionally on a graph to find distance dependence, and then that value was used to calculate the value for dipole moment, which is then plugged into a code. So for this code, the system includes just the magnet, and the surroundings include the space surrounding the magnet, and the rest of the universe. So the initial conditions in this situation are that we simply have a magnet, which is a small cylindrical object in the code, which is producing a permanent magnetic field, where the dipole moment is 1.77 and the magnet is alone. So the assumptions that requires are that the relationship for magnetic field based on dipole is accurate for this situation. The magnet is alone in the universe with no other magnetic field sources or current in the magnet. The data is detected by the magnetometers in the cell phone, and it was accurate. It was assumed as accurate. So here's the code that I used to simulate this behavior. So we start by designating some constants in the magnetic dipole as calculated. We then calculate the magnetic field based off of a variable r. So we can apply this function later in the code to find magnetic field at certain points. Then we draw a number of arrows for on the axis of the dipole and perpendicular to the axis of the dipole to represent field strength and direction at those points. We then designate some directions. So finally, we calculated the magnetic field perpendicular to the axis using this formula, which basically finds the magnetic field based off of the distance, that original formula that I had given. So to discuss the results that I got, essentially magnetic field strength in any direction from the dipole decreases as the distance increases. This matches pretty well with the model. However, the field strengths that were found were about a quarter of what was actually observed using observational data. So the sources of error that I had found include the fact that the magnetic field of Earth was not constant and perfectly accounted for, so small variations likely cropped up there. The iPhone magnetometer that I used is not a precision instrument, so it's likely that there are some errors there. The placement of the magnetometer chip, the angles and the distances wasn't perfectly precise, as well as the fact that nearby there were electronic devices nearby which very heavily affected the magnetic field. So the answer to the two questions that were given, the axis of the magnet, what if the axis of the magnet was not aligned with Earth's magnetic field as it was in the experiment? In that case, we'd observe an extra component of the magnetic field, which would cause the apparent magnetic dipole to appear as if it was pointing in a different direction and it was a different strength. However, this effect would only be on the x and y components, as Earth's magnetic field does not travel in the z component. So to answer the other question, what if two magnets of identical properties were stuck end to end and the experiment was rerun? The magnetic field observed would become stronger due to magnetic superposition. In addition, the requirements for the experiment where a certain magnetic field must be discovered and the distance recorded would be different. The distances would be shorter as the magnetic field strength would be higher.